In the government's latest response,
You must stay at home.
Master of the house, doling out the charm.
It's very important that everyone
know that you are not alone.
Scary. I'm allergic to bees. So, in this lesson, we're going to talk about the nomenclature of, or naming, of amines or amides. Allergic reactions tend to be, largely due to an overproduction of histamine, which is an amine. So today we're going to look at how we name them. Now, histamine here is a fairly fancy one, but histamine is not the actual name for it. It's the common name. It's not the IUPAC name for amines, sorry. Okay, so by the end of this, you want to be able to identify and draw amines and amides, as well as recognize the functional group that makes up, amines and amides. So here's your vocabulary. If I can just get you to pause the video here, hit subscribe and like, why not? And that way you'll have this to refer back to as we travel on down the road. So we're going to start with amines. So this is our functional groups, right? We have ammonia, which it's very like, and then we have 1 supernaut, 2 supernaut, 3 supernauts, or a primary amine. That's what that means, the one there. And that means that it is only attached to one carbon or one R chain. And then we have the secondary amine, which is attached to 2, and the tertiary amine, which is the most interesting and scariest, which is attached to 3. Now, this is important to realize. Amines are a terminal group. They only ever exist on the terminal carbons. If they're not on the terminal carbons, they tend to be breaking up the middle of it, so it becomes middle of the chain, R chain, so it becomes the terminal carbon. So if it substitutes the place of a carbon, that one, so just say you've got butane, which is carbon, carbon, carbon. It substitutes that middle one, it becomes carbon, amine, carbon, so it's a secondary amine, but it stops being butane, right? Propane. It becomes methane with a methyl group, so methenamine. That's a good way to say it too. I like the word methenamine. And that's that. So it's a terminal functional group. It's always on terminal carbon. So amines. This is very hard. It's this functional group right here. The best way to write it is R-NH2, but it's not always the H's. First thing we do is we recognize the highest order functional group. In this case, it's going to be the NH2, the amine group, and that gives us the suffix amine. And it's called an amine. So we identify the longest parent chain. It's got all the doubles that it can have, or triple bonds. It's got the maximal number of carbons that include that, as well as including the parent functional group. Then this gives us the prefix, as in the meth, prop, bute, eth, so forth all the way. The number, we number the parent chain, giving the one which the amine is attached to, the number 1. Okay, so it's always got the lowest possible number. We identify any double or triple bonds. This takes it, might be from, say, propanamine to propenamine or propinamine. These just seem like fun words to say. And it gives the infix -ine. We identify and add the prefixes. So tri, di. So for any components that have 2, for example, if you have 2 amines on either end, it becomes diamine, and so forth. We place the numbers prior to each component. There's a fun one here. So numbers are separated by commas, letters and numbers are separated by hyphens. But if a side chain or lower priority group, anything, is attached to the N, so see if this one of these H's here was replaced with a methyl group. We can't give it a number because it's not attached to a carbon, it's attached to the nitrogen, so we call it N. We give it that number there. So for example, if we had a butanamine, so four carbons long with an amine at the end, but the amine has a methyl off that, then it becomes N-methylbutanamine. So yeah, that's just a fun little quirk of it. So here are a couple of examples. We get our first one. There's an amine group. We number it and we call it heptan 1-amine. You can just call it heptanamine. It doesn't actually matter. And the reason it doesn't matter is because it's only one amine group, and they're always terminal. If we had a diamine, we'd have two of them off the one carbon or one off the back and the front, and we definitely would need to number that. So we don't actually need to number it heptan 1-amine. It's just good practice. It's always good practice to do that. So I'm going to do it throughout. So here we have an amine group. We have a prop-2-ene, which is interesting. We've got a double bond down here. So it's prop-2-ene. We put that together and it becomes prop-2-ene 1-amine. It's fun to say, isn't it? Prop-2-enamine or prop-2-ene 1-amine. Then we have this amine in the middle here. This is a fun one. This actually has two names and they're both kind of right. Again, we'll go with the second name, but I'll give you the first name just for fun. And that would be, because these are three methyl groups coming off an amine, trimethylamine. That's fine. You could call it that and you'd get away with it. However, the way we would do it with the RU-Pack is we'd have a methane group here, methane, so methanamine, with an NN-dimethyl. So NN-dimethylenamine. That's fine. And then NN-dimethylenamine. Then we come over here and we have a diamine. That's right, there's two of the bad boys. It's a propane group, numbered from each side, doesn't matter. And this would be numbered propan 1,3-diamine. Our last one, it's the most fun one of the lot. So we have an amine right in the middle there. If we count from the left, we can tell that it's a butan, there's a butanamine, or a butyl group. We're not sure, so we're going to count the other way. Oh, it's also a butan or a butyl. So what that means we have is N-butyl-butanol-1-amine. No, hang on, let me say that better. N-butyl-butan-1-amine, or N-butyl-butanamine. So that's cool, right? Like, that's our different ways of naming that. So let's look at amides. Look at amides. Seamless edit. As the computer crashed. An amide is another functional group. It's another terminal functional group, but the terminal here is the C, which goes off to an R, but the C with a carbonyl group and an amine group. So the carbonyl plus the amine make it an amide. Now here we've got some asterisks where there could be H's, and that's because they can be H's or R chains, as in we could have a primary amide, which would be C with a carbonyl and an NH2, or it could be a C with a carbonyl, an N, an H, and another alkyl group, or two alkyl groups, primary, secondary, or tertiary amide. So let's have a look at the rules. First thing we do is we find the longest chain possible with the amide attached, and that gives us the suffix amide. Then we identify the longest, just as we did with the amides, right? Longest chain that contains this, contains maximum number of double bonds and the maximum number of carbons, and that gives us our prefix, meth to dec, well, beyond, but whatever. We number the parent chain, giving the C with the carbonyl, numero uno. It's the first carbon, and everything else comes off that. So we start numbering from there. We identify any double or triple bonds. That should be included in there. And that will give us our infix, an, ene, ein. We identify and add any prefixes, di, tetra, like if you've got two amides, it might be diamide, to the identifier of any component. And then we place positional numbers. Now remember, the positional numbers have either a 1 or a, like a 1, 2, 3, whatever it is, or on ours they can have an N, because if it's attached to the carbon, to the nitrogen, it's not attached to any of the numbers of carbon, so we give it an N. And we separate numbers and the N's with commas, and we separate numbers and letters with hyphens. And the N's for the nitrogen shows that it's a, it makes it count as a number in that situation. And we see that here. Here's N-methyl-butanamide. And that's because we've got a butanamide right here. And right there, we have a methyl group. Now, with the amines, we numbered them. In this case, we're not going to number the amides unless we need to, because they're on the terminal carbon. It's just, we can do it. We don't have to do it. It's good practice to do it, but we're going to show you what it looks like when you don't do it, which we didn't in the other one. Okay, so first one. Let's go. We've got an amide. Sweet. And there's only one carbon, which means that one is methanamide. Second one, we've got the amide. We count the chain up. It's 2, so it's an ethan or an ethane, and we have ethanamide. This one here, again, we're at an amide. We add it up. It's a hexane, and it's a straight one, so it becomes hexanamide. Again, the numbering's unnecessary. We could number it here. On these ones, we definitely shouldn't, because it can only ever be 1, or propane for that matter. So here we have another amide. Added up, we've got propanamide. Then we get a bit spicy, right? Because we've got an amide, we've got a butane, or a butan, and a bro, a 2-bromo. So we have a chatamide. No, a 2-bromo-butanamide. That was just a little joke for me. Here we have a secondary amide. So we've got an amide. We work out which one's the longest. It's the one on the left. So we number from there, which makes it, again, butan. So it's a butanamide with an N-ethyl group, because there's 2 carbons right there, see? So that chain's too long. So it becomes N-ethyl butanamide. Then we have a tertiary one with diethyls. So we've got amide, propane, so it's propanamide, N-N-dimethyl. So we put all that together, we have N-N-dimethyl propanamide. Yeah. So if you have any questions, now that the computer's working and there's no more problems, if you have any questions, put them in the comments below and we'll get back to you as soon as we can. Thank you for watching, and we'll see you next time. Bye now.